Newton's first law of motion, also known as the law of inertia, states that an object at rest will stay at rest, or an object in motion will continue moving at a constant velocity in a straight line unless acted upon by an outside force. This means objects naturally resist changes in their state of motion. In the first example, Rikai is sitting still, while Ryan, the dude, pushes him, and Rikai starts to move and roll off the ground, demonstrating that an object at rest stays at rest until something, like Ryan's push, forces it to change. Eventually, Rikai comes to a stop because of friction, the force between the surface of the body and his body that slows him down. In the second example, Ron is walking steadily when he bumps into Rikai. When he jumps backwards while Rikai stays still, it shows that even though Ron is in motion, he only changes his movement because of the external force of the collision with Rikai. These examples perfectly illustrate Newton's first law, showing that objects either stay at rest or keep moving until something interrupts them. Newton's second law of motion explains that the force acting on an object is equal to its mass times its acceleration, or F equals ma. This means that the more mass an object has, the less it will accelerate when the same force is applied. In the video, Taylor, being the larger object, pushes Addison and Hannah, and they fly backwards a lot because they have a lot less mass, so they accelerate more. Taylor, on the other hand, barely moves because her larger mass requires much more force to achieve the same acceleration. This demonstrates how mass and acceleration are directly linked to the force applied in Newton's second law. Newton's third law of motion states that for every action, there is an equal and opposite reaction. This means that when one object applies a force on another, the second object applies an equal force in the opposite direction. In the video, Ohm and Rikai push off each other simultaneously, and as they do, they both move backwards at the same rate. This happens because the force Ohm exerts on Rikai is matched by the force Rikai exerts on Ohm, causing both of them to push away from each other with equal and opposite forces. As a result, they move back to the wall at the same time and the same rate, perfectly demonstrating Newton's third law in action.